So for the unit exam, okay, our key points here. Okay, we started out first day reviewing scalars and vectors. All right, so what quantities were scalar, what quantities were vector? Okay, what were our scalar quantities? Time, distance, and speed. Yeah. Okay. We could also add to that energy and work, but we don't cover those in this unit. Okay. And our vector quantities then would be velocity, displacement, and acceleration. Right. Those would be force, which again isn't in this unit. But okay, those would be our vector quantities. Now, does that mean that you're going to need to know that because I'm going to ask you directly which of these are scalar and which of these are vector? Probably not. I mean, there could be a multiple choice question like which of the following is not a vector quantity or something like that. But what's more important for knowing which things are vector is like if you get a question, let's say an acceleration problem, and it gives you a bunch of information that asks, can you calculate the final velocity? Well, if you don't put a vector on your answer, are you going to lose mark? Yeah. So it's something simple like that. Okay. Or in a question like that, one of the the initial velocity is negative and the acceleration is positive. Okay. Well, then you have to make sure that you reflect that in your math. That's where vectors and scalars is kind of important. Okay. So those were our vector ones. Okay. V equals d over t. There could be like a simple v equals d over t problem in the multiple choice for 1 mark. Okay, but it's not something I'm going to spend a 4-mark written response item on. But it is something that would be part of your projectile motion problems with the horizontal parts. Okay, so certainly using v equals d over t is something that you'll need to know how to do. Okay. All right, so that was like day 1 and 2. Then, this isn't exactly the order we went in, but it's the order I brainstormed it in. Graphing. Okay, we went over 2 different types of graphs. Position versus time and velocity versus time. Both are on the unit exam. Okay. You will be expected to be able to do the same types of operations and interpretations of those graphs that you were asked to do in the analysis of your 2 labs. Okay, there's going to be nothing on the exam that wasn't part of your labs. Okay, so being able to figure out the velocity from a graph, or the acceleration from a velocity time graph, or identify what kind of motion is occurring from this shape. Okay, things like that. Interpretation, calculations, using y equals mx plus b, right? But like the stuff that's on the lab you handed in today, that's on the test. Okay, like almost identical. So being able to show me that you can replicate those skills on an exam is what I'm going to ask about graphing. So we could have our y equals mx plus b stuff, okay, like this. If this was a velocity versus time graph, what would the slope of that line represent? It'd be the acceleration, because it would be the change in y, meters per second, divided by the change in x, time. Okay, change in velocity over time, that's acceleration. Okay, and if I wanted to calculate, let's say, the total displacement, okay, well, then I would have to find area underneath the line. So like this rectangle, that triangle. Is there a shortcut for that?
Yes.
What is it? Yeah, the formula, the one that calculates the area of the rectangle and the area of the triangle. That one? Okay. Being able to recognize that kind of thing. Is there a longer way to do it that's equally valid? Yes. Do you want to do the longer, equally valid way on a test? No. Probably not. Time is usually a factor, so if you can do it quickly, that's always a good idea. Right. Could you be asked to calculate using y equals mx plus b, or sorry, extrapolate beyond the graph? Absolutely, it's something you were asked to do in class and in the lab, so expect that those same things are going to be on there. If I have a position versus time graph, what does the slope represent? Velocity. Okay, can I calculate displacement from this graph?
Yes.
How do I do it?
Isn't it VF?
This, right here.
Oh,
Right? On a position time graph, I can read the position and the time. Is that what you were asked to do in your lab? Yes, it was. Okay, so like I said, it's exactly the same stuff that was on your 2 labs, okay, expect to be asked that same stuff. All right, acceleration, problem solving. Okay, there's definitely an acceleration problem on its own in the written response. There's also one in the multiple choice that's fairly simple, okay, which is why it's only in the multiple choice. Okay, but the one in your written response section of the test is a little more involved. Okay, so being able to pick the correct formula. And also, it's part of projectile motion. Being able to solve acceleration problems is part of the vertical part of any projectile motion problem. So definitely know your formulas, how to manipulate them, okay, things like that. Okay, vector addition, definitely. Okay, there is a vector component addition question in the written response portion of your unit exam, and there's a couple of questions in the multiple choice about like the nature of vectors, the nature of vector addition, stuff like that. Not like calculations per se, but demonstrating your understanding of the concept, okay, as opposed to the skill. Okay, you're demonstrating your skill by doing a problem, okay, but you're demonstrating your understanding by answering multiple choice questions about it. Okay, so there'll be one like we did on the quiz, you know, like one that's horizontal and one that's angled, or one that's vertical and one that's angled, something like that. That'll be the type of vector addition question you'll get in the written response. And boat question. There's a boat question in the written response part of your unit exam. Right, so remember that all vector addition is done tail to head. What mistake got made a lot on the vector assignment on the boat questions?
Probably
No, it wasn't the tail to head part. Okay,
Rowing versus.
rowing versus going is something we'll certainly have to identify, but the mistake that was made on the vector assignment was that people knew the distance across the river and used their resultant velocity to calculate how long it would take to get across. Can I use something that points this way with something measuring this distance? No, they don't point the same direction. Okay, I would have to use the rowing velocity, or if it was a going across, the resultant velocity, to figure out how long it would take to get across. Okay, so that's the one thing that we have to remember. I can only use vectors with the same direction together. It's also why we break up the projectile questions into horizontal and vertical. It's because I can't use horizontal information with vertical information other than time. Okay, which is also true for the boat questions. The only thing that applies to both downstream and across is time. Okay, because it's scalar. Everything else is vector, so the vectors have to match. Okay, and then projectile motion, problem solving. So there will definitely be, okay, one of each kind. So a projected horizontally question and a projected at an angle question. Okay, so when we look at it like that, it doesn't seem like there's all that much on the test, but obviously there's a lot of different ways I can ask those things. So on your test, on your unit exam, there are 17 multiple choice questions. Okay, and the multiple choice questions ask like fairly straightforward things, or they're checking your understanding. Calculation is only a very small part of the multiple choice questions. If there is a calculation, it's something incredibly straightforward. Okay, so you know, can ask the difference between scalars and vectors. You know, maybe giving you a situation to calculate the displacement, which would be something you could do in your head. Like you wouldn't even require your calculator. That kind of calculating. I think there's only like 2 out of the 17 that you actually might have to enter into your calculator. Okay, the rest is all understanding, interpretation of graphs. So there's a couple of graphs in there where it's just like interpretation or a simple calculation. about vectors and a couple of things about the nature of projectile motion. Okay, that's what's in the multiple choice. So there's 17 multiple choice questions, and there are 7 written response items. Okay, so those would be problems like you would have on a worksheet, okay, in class. 2 of them have multiple parts. Those are the graphing questions. Okay, so the 2 graphing questions, okay, have like an A, a B, a C, and a D. Okay, so it's asking you to do a number of different things using the graph. Alright, so as I said, you've got 1 of each type of projectile motion question. Above question. An acceleration problem. A velocity versus time graph. Position versus time graph. And a vector component addition problem. That's your test. Okay. Now, the multiple choice, that's going to be done on the zip grade forms. Okay, I'm sure you guys have used those before. Okay, where you fill in the letter, and then I can scan it with my phone to mark it. Okay, that's how the multiple choice will be scored. So I need you guys to make sure that you bring to the test a pencil. Okay, you must bring a pencil, at least one, to the test, because you don't want to do the multiple choice in pen. Okay, because what inevitably happens is this. Okay? People are like, okay, I've read the question, I think I got it, I think I understand what it wants. The answer is A. And they fill it all in, good and dark with their pen. And then they're like, oh crap. No, it's not. Oh, it's C. And they fill that one in, good and dark with their permanent pen, and then they go like this. And then they're like, oh no, I misread that number. I punched in my calculator wrong. And then they do this. Do you know what my phone says when I scan that?
Wrong.
It says it's wrong. And my phone is right. Okay? It's wrong. It's not all 3 of those. And my phone knows that. Okay? But it doesn't understand this. And neither do I. Okay? I am not going over your multiple choice form in detail to see if you've done this. Because if you've done this, I'm telling you right now, don't do this. Okay? It's not this one. It's done with a pencil so you can erase it. Okay? My suggestion would be, the first time you go through the multiple choice with your pencil, just do that. And then when you're sure, after you're done checking it over, then fill it in good and dark with your pencil. Okay? That's good multiple choice test taking strategy. Okay? For the written response questions, the point value, okay, is written at the end of the question in brackets. Okay, so if you see that at the end of a question, that's telling you that question is out of 4 marks. Okay, or that part of the question is out of 4 marks. So if it was like the graphing question, you might have part A and it's only out of 1. Okay, and then part B would be out of 3. Right? If something's only out of 1 mark, how much calculating do you have to do?
None.
Yep. If something is out of 1 mark, the answer's right in front of you somewhere. Okay? Because I would give you more if it required you to like put in a formula, plug numbers in, and actually do a calculation. It would be worth more than 1 mark. If something is worth 1 mark, the answer is right there. Okay? So just know that test taking strategy.
Do we get a formula sheet or do we have to memorize?
The formulas are on the front of the exam. You do not get to use your formula sheet because I don't know how many notes to self you have written on it since the beginning of the year. Okay, so yeah, you get all the kinematics, like basically the kinematics section of your formula sheet is on the front page of the test, so you have it there. Okay. Make sure you show all your work on the written response part. Okay, this happens all the time, even though I mention this, but Some people are just like, I don't need to show my work. I'm that smart, and I never make mistakes, so I don't show my work. And all they do is write an answer. And if they've punched something in wrong, or their calculator was in radians because they were just in math, they're gonna get nothing. Because all I'm gonna see is a number that's not the right answer, and I have nothing else to look at or give credit for. Okay, so show all your work. If a question is out of 5 marks, have your givens written down, the formula you used, show your manipulation, show your numbers plugged in, show your final answer. Every step, okay? They're all worth a mark. If for some reason something goes wrong on the calculator, okay, and everything else is right, you get 4 out of 5. You lose a mark for being, terrible at punching numbers into your calculator, but, okay, beyond that, I know everything else was right, okay? And if you show all of that, then I have proof that says I can give you 4 marks because it's there. If that stuff's not there, then I can't. Okay, so showing your work is a big deal. All right, other little things about the test. I will let you guys write into lunch hour a little bit. Probably give you like an extra 15, maybe 20 minutes if you need it. When I made up the key, it took me 18 minutes. Okay, now I don't expect that you can do it as quickly because I also made the test, so I should be able to do the questions fairly quickly. But I figure the test should take you between 3 and 4 times as long as me. Okay, well, 4 times 18 is still less than 85, so you should be able to finish it in the time provided, but I will allow an extra 15 minutes at the end of class. Okay. Now, obviously, if you have an allotment for extra time through learning support or any other accommodations through learning support, those will be given to you, okay, and I will have made arrangements, and your test is probably already in learning support already. Okay, so if that applies to you, okay, you know who you are, and that'll be taken care of as well. Okay, the tests will be marked and returned. We'll go over them the next day. So on Friday, we'll go over the tests. Questions from you guys?
People who are missing, I might build like the second version of the test, are we gonna write it in class time
On Monday. Yes.
or Tuesday?
Because Monday's Thanksgiving. Okay, so yes, if you are not here on Thursday, okay, then you will write a different version of the test, obviously, because I'll have gone through all the answers to the other one. Okay, and I don't want to have you write it on Friday because classes are too short. Okay, so yes, that's what will happen.
Can I have a quiz next Tuesday?
No, because I won't have taught you anything to quiz you on. All right, anything you want me to go over in more detail? Types of questions you'd like reviewed? Tegan?
By vector addition, like what do you mean?
I mean, like what we did on the quiz. So, like on a quiz, add these vectors. So, like 200 meters due east and
And then just find the
120
result.
meters, like at 40 degrees south of east, right?
And then find the result.
Find the result.
Okay,
The
perfect.
vector components. Okay, what else, guys?
Can we go over a boat question?
A boat question. We can certainly go over a boat question. Okay, so here's a boat question. All right. Person can row at 10 meters per second and they are rowing directly across. Okay. The river current is 3 meters per second and the river is 1,350 meters wide. I want to know the resultant velocity of the boat and how far downstream they will be when they get across. So, the first thing you're asked to calculate the resultant velocity of the boat, and it was relative to the shore. So that means this angle here, because that's relative to the shore. Okay? So if I want to get the magnitude of this, it's just Pythagorean theorem. Okay? So it'll be that this resultant velocity is 10 squared plus 3 squared. Okay? So whatever the square root of 109 is. Okay? plus 3 squared. All right, so we got 10.44 meters per second. Then we need theta, okay? But because I'm looking for this theta, I'm not going to use this triangle. I'm going to use this one instead, okay? Because that'll get my angle inside the triangle. So that'll be the inverse tan of 10 over 3. You could have done the other one and just gone 90 minus as well. That would have got you. All right, so we're looking at 73.3. We only have one significant digit, but we'll say we had two, okay? So we'll say 73 degrees from shore, okay? So our final answer would be 10 meters per second, 73 degrees from shore. I would make that have 3 significant digits on a test so it was different from the other velocity there.
Couldn't you just get the inside angle and just minus it?
Yeah, I just said that. Yeah, we could do 90 minus that. That would work. That's fine. Okay, so now that I know the resultant velocity, I'm never going to use that number again. Okay, it's irrelevant to figuring out how far downstream I'm going to be for a rowing across question. For a going across question, it would be really important. Okay, but this is a rowing across question. So I know I can go across at 10 meters per second. I know it's 1,350 meters across. So 1,350 divided by 10 means this should take 135 seconds. Okay. Since it's going to take 135 seconds to get across, I'm going to be going downstream at 3 meters per second for 135 seconds. So the distance downstream will be 3 times 135, V times T. Okay, so 135 times 3, I'm going to end up 405 meters downstream. Okay? The key here is use quantities that point the same direction together. All right, if this was a rowing across question, okay, a going across question, our resultant would point straight across, okay? And so we would use the resultant with the 1,350 meters to figure out how long it would take to get across. It would be longer than 135 seconds, okay? Because the current would slow us down, okay? Which would mean we'd end up further downstream because we'd be in the river for longer. Okay, everybody all right with that idea? Okay. All right, what else? What other questions we got?
Can we do an acceleration question?
Sure. Okay, there you go. There's an acceleration question. Okay, so in this one, we're told that the ball is thrown upwards. Okay, so VI is 14 meters per second up. Okay, what is its velocity? So VF, okay, when it is 2 meters above where it was thrown. Okay, so what else do I have here? Acceleration. Okay, so these two numbers are up. That one is obviously down. All right, so if I'm going to find that, I got to use VF squared equals VI squared plus 2AD. Okay, and I just have to square root it. So VF will equal the square root of VI squared plus 2AD. Okay, I have VF, A, and D, so I can just plug them into the formula. Okay, 14 squared plus 2 times negative 9.81 times 2 meters. All right, so 12.5, actually we only have one significant digit, so 13. No, that's two significant digits. 1 times 10 to the 1. That's terrible. That number, that's how fast. 12.5 meters per second. Okay. I will not have anything with one significant digit on this. It's just crazy. All right, questions on that one? That makes sense? I mean, obviously your acceleration question could be that formula, it could be d equals vit plus 1/2 at squared, d equals vft minus 1/2 at squared, vf minus vi over t, okay? It could be any one of the formulas we worked with, and any one of those formulas could be gained for a projectile motion question. You may.
Can we do a question on like, either position, time graph or velocity? Crazy.
It's like I was ready for these questions. You guys are asking good questions though. Okay, so we got a position versus time graph here, okay? And the equation for the line is y equals 1.53x plus 3.23. For 1 mark, what's the velocity of this object?
1.53.
Okay, 1.53 meters per second. I would say that should probably also have a positive
Yep.
on it. Okay, maybe on a graph this might say position in meters north or something like that. Be on the lookout for that because a vector could be on the y-axis. Okay, how long would it take this object to reach a position of 75 meters? Okay, how long to reach a position of 75 meters?
49 seconds.
Okay, I don't know what it is, I haven't calculated it myself. Okay, if I'm looking for how long, what am I looking for?
X.
X. Time is on the x-axis. Time measures how long. Okay, so that's going to mean then that x equals y minus b over m, 75 minus 3.23, okay, divided by 1.53. Okay, 47 seconds. Okay. Are you all right with that? Okay. And I could do a similar thing. I could ask you, what would the position be after 50 seconds? Okay, if I ask you what the position is going to be, you're looking for y. Okay, so you just plug in 50 for x and solve, and you're there. Okay, that's the kind of thing I might ask. I could also ask, what type of motion is being shown here?
An object is accelerating at a constant velocity.
You can't accelerate at a constant velocity. It's one or the other.
Oh, sorry, the velocity is at a constant acceleration.
Well, yes. Okay, that'll buy as long as you put on there a constant acceleration of.
Positive. Or zero.
Right. Okay. But you should never use acceleration and constant velocity in the same sentence because they don't go together. Right.
So
This is an object
it's
traveling.
at a constant acceleration or constant velocity.
Velocity. This is something traveling at a constant velocity because its position changes by approximately the same amount every second. Okay? In a positive direction. That's constant velocity. If this was a velocity versus time graph, then it would be a constant acceleration because the velocity would be changing at a constant rate. Okay? All right. I still left all the solutions on here. Okay. So, if I gave you a velocity versus time graph that looks like this one. For 1 mark, what's the acceleration?
2.3 meters.
Yeah, positive 2.3 meters per second squared. Okay, make sure you put the squared on there. You'd be surprised how many people lose a mark because they put the wrong units on an acceleration in a question like that. Okay? Calculate for me the displacement of the object to 30 seconds. 30 is the end of the graph. Okay, in case you can't read that, this is y equals 2.3 times x plus 4.63. Okay, so if I want to calculate the displacement of this object, I basically need, okay, the area underneath the line, right? Now, for this rectangle here, okay, if I actually drew that as a graph, that would be an object traveling at a constant velocity, which is why that part can be calculated by taking the initial velocity and multiplying by time. Where do I get the initial velocity from? It's the y-intercept. this y-intercept tells me how fast it's going at time 0. Okay, so from this formula right here, m equals acceleration, y equals final velocity, b equals initial velocity, x equals time. Okay, that's what I can get straight from the equation of the line. So I know the initial velocity, I know the time is 30 seconds because that's what was told to me on the graph, so I should be able to use this, d equals vi times t plus 1/2 at squared as a quick way to get the area under the line. I could also just, find the area of the shapes, figure out the height of the triangle and whatever and do all that. It would get you the same number, but it's a lot more work. Okay? This will do it quickly. So we would have 4.63 times 30 plus 1/2 times 2.3 times 30 squared. And we would have our total distance, our total displacement on that. Okay? As long as we recognize what we have, okay? That's not me memorizing that I can do that. That's me looking at my graph and going, all right, I have VI, I have A, and I have T. How can I get what I'm looking for from that? Doing the least amount of work. Okay? Now, if it doesn't click to me that I have that formula, there's absolutely nothing wrong with finding the area of the rectangle, finding the area of the triangle. It still works. Okay? It still shows you that you understand how to get something from a graph. Either way would be fine, because either way is perfectly valid. Okay? All right, what if this graph was irregular? So it wasn't just a nice sloped line like that. Would it change what I do? Yeah, I'd have to section it out. I wouldn't be able to do this anymore, okay? But if my graph went like this and like this and like that, okay, well then I would have like, right? So like this rectangle here, actually all the way across, this rectangle and this triangle that I'd have to get the areas up there, something like that. And it still works out to the same thing. When I'm calculating those areas, I'm taking average velocity and multiplying by time to get displacement. Okay? That still works. Okay? It's perfectly valid to do that in any way necessary from the graph. Okay, what else? Okay, object goes off the cliff at 10 meters per second, hits the ground 25 meters from the base of the cliff. How tall is the cliff? Yes, or maybe not. Might not be that tall. Okay, so horizontally, I know two things. I know the speed, 10 meters per second, and I know the distance, okay, 25 meters. So I can find the time, d over v, 25 over 10, is going to be 2.5 seconds. Time can come over here, 2.5 seconds. All right, now I can calculate the height of the cliff, 1/2 at squared, because vi is 0, I'm not even going to bother to write it. Okay, so 1/2 times 9.81 times 2.5 squared. All right, cliff's 31 meters high. Big cliff. Although 30 meters, I mean, it's a long way to fall, certainly, but big cliff would be 100 meters. Yeah. Depends how afraid of heights you are. Some people stand at the top of a set of stairs and go, and I mean like 2 stairs. Some people are not afraid of heights. Yeah. All right, what else?
I guess since we did the horizontal one, then I can do an angle one.
Like that?
Yes.
Okay. So, I would like you guys to calculate the two things we always calculate on a standard question. I want the horizontal displacement, assuming launch and land are equal in height, okay, and maximum height of the projectile. It's launched at 50 meters per second, 30 degrees above the horizontal. Things I can calculate off the bat. Initial vertical velocity, That'll be the sine of 30 times 50, which will be positive 25 meters per second. Since launch and land are at the same height, what's VF? Negative 25 meters per second. Okay, horizontally speaking, our constant horizontal velocity will be the cos of 30 times 50. Okay, so 43.3 meters per second for that part. Okay, and I'm looking for the horizontal displacement. That means I need time. So time will be VF minus VI over A. So negative 50 over negative 9.81. Okay, it's 5.10, we'll say, but I'll keep all the decimals in the calculator. Okay, so time equals 5.1 seconds. Okay, we plug that in here. D equals V times T. So we take that number and we multiply it by the velocity we calculated earlier. This thing is going to travel 221 meters. I think we only have 2 sig digs though, so that'll be 2.2 times 10 to the 3 meters horizontally. To calculate the maximum height, that's the vertical displacement at the halfway point where VF is 0. So that's going to be VF squared equals VI squared plus 2AD. Okay, and I'm simply going to manipulate for D. So that'll be 0 squared minus 25 squared divided by 2 times negative 9.81. All right, so we're looking at a maximum height of 32 meters. Okay, ringing a bell? All right, tomorrow we will finish up some more involved projectile motion problems, okay, and go over your acceleration labs in class, and then obviously Thursday is your unit exam. Bring to your unit exam the following things: pencils, pens, calculator, and yourself. You don't need to bring anything else. Okay, you're getting the formulas on the front. Okay, your cell phones will be collected at the beginning of class in a bin at the front of the classroom, because obviously you can't have those on your person during a test. Okay, and when you're done, you can come and grab them. Okay, same as usual. All right. Any questions from you guys? All right.